Hi everybody, welcome back to my channel on Feynman integration. Today we'll be doing this integral. I'm going to be going through it a little bit quickly since we've done integrals similar to this already, and we're going to be utilizing these facts, which I really won't go over because I've already done that on this channel. Alright, so our first step, we're going to create a function of t that's equal to the integral from 0 to 1 of x to the t over x squared plus 1 dx. And we're also going to write f prime of t right off the bat. So using the Leibniz rule for differentiation under the integral sign, we can take a derivative with respect to t of the integrand and get the derivative with respect to t of the entire function. All right, so that's just going to give us x to the t natural log x over x squared plus 1 dx. All right, then we can note that if we evaluate f prime at 1, we will get back our original integral. If we plug in 1 for that t, we just get x times natural log x over x squared plus 1 from 0 to 1, which is exactly what we want. All right, next step, we need to rewrite our f of t using this fact. So I'll go ahead and do that right now. So that means that f of t is equal to the integral from 0 to 1 of x to the t times the sum from n equals 0 to infinity of negative 1 to the n x to the 2n and then dx. Using Fubini's theorem and bringing this x inside there as an addition to the exponent on what we already have for x, basically meaning this is going to become x to the 2n plus t. So we're going to rewrite it one more time. F of t is equal to, let's see, we want the sum first now. So the sum is still going from 0 to infinity. And we'll have this negative 1 to the n times the integral from 0 to 1 of x to the 2n plus t dx. And this part right here is just 1 over 2n plus t plus 1. All right, so let's rewrite our f of t up here. That means that our f of t is equal to the sum from n equals 0 to infinity of, let's see, we're going to have the negative 1 to the n over 2n plus t plus 1. All right, so there's our good f of t right there. All right, let's go ahead and take f prime of t using this one. We'll note that this is just 1 over, this is 1 over 2n plus t plus 1. And if we take the derivative of that, we will get negative 1 over 2n plus t plus 1 all squared. All right, so that means f prime of t is also equal to, let's see, sum from n equals 0 to infinity. We still have the negative 1 to the n over negative 2n plus t plus 1 squared. All right. Now all we need to do is plug in 1 to this and we'll have I. So let's do that. That means I is equal to negative sum from n equals 0 to infinity of negative 1 to the n over 2n plus 2 all squared. All right. Looking good, looking good. Okay. This is almost this. Let's see. We could get rid of these 2's by factoring out a 1/4. So let's do that. It's become an n plus 1 squared. And we'll have 1/4 on the outside. Let me rewrite that a little bit neater. -1/4. All right, and then we know by the rules of sums that we can subtract 1 from all our n values inside the sum as long as we add 1 to the index. So we'll do that. This will become an n squared. This will become to the power n minus 1. This index will become 1. Okay, so now what? Well, we can either add or subtract 1 from the exponent, and then that will have the effect of just multiplying the entire thing by -1. You see, this is just going, when you raise this to successive powers of n, you just get -1, 1, -1, 1. So if you change the power by 1, you will get the negative of whatever it was before. All right, so now we have I is equal to 1/4 this thing, which is this thing. In other words, I is equal to -pi squared over 48. All right, guys, that's it. Hope you enjoyed that.